Hi there, everyone. Welcome to this Thorogood Associates webcast, where we'll look to demystify agentic AI and reasoning and thinking models, which has been a real hot topic in recent times in the data and AI space. So first of all, before we get into any content, I'll give a quick introduction to the presenters for today's session. So my name is Ethan Hinton, and I'm a senior data and AI consultant with Thorogood, and I'm joined by my colleague, Aaron Chalmers, who you'll hear from a little bit later on. Aaron is also a data and AI consultant with Thorogood as well, and we're both based out of Thorogood's London office. So with the intros out the way, what are the objectives for today's session? So firstly, we want you to get a good understanding of what agentic AI is and how it adds to generative AI. And to do this, we'll explain the 6 important patterns of agentic AI, so the things that make agentic AI what it is. We'll also try and give you some idea of how agentic AI can be used in your business through a use case driven demo that Aaron will present shortly. And then finally, we'll talk a little bit about how Thorogood can help you and your business to design and implement agentic AI solutions. So in our previous session on demystifying AI, we looked at explaining how generative AI came to be, and we did this using the timeline that you can see now on the screen. I won't go into too much detail about what you see here, but I really do recommend that you go back and watch that episode if you're interested in the roadmap to generative AI over the many years and decades since the 1950s. But what I do want to talk about is what's happened since then, since this timeline finishes there on the screen, because a lot has happened. So firstly, we've seen agentic AI really come of age in the past year and a half. So in this time frame, I'm sure you've been hearing more and more about agentic AI, and that's probably what's led you to this webcast in the first place. Then later on last year, OpenAI released their O1 model. And O1 is particularly important as it was the first major model to use reasoning capabilities. And what this means is that instead of just generating output text straight away when a user asks the model a question, it first jots down its thought process before reviewing those thoughts and coming to a final answer. And this kind of pattern made it much easier for the model to work out logical and multi-step problems. So it became much more effective at doing that compared to models that had come out previously. So then when we look at this year, early on, we heard NVIDIA CEO Jensen Huang declare that we're in an age of agentic AI. And shortly after that, DeepSeek, a Chinese model developer, released their R1 reasoning model, which stood out because it matched the performance of OpenAI's O1 model at a far lower cost. And this really shook up the market. And I'm sure you probably heard quite a lot of this in the news earlier this year, as it was quite a big thing. But then finally, that brings us to today. And now we're seeing businesses start to explore agentic AI and use it to automate processes that could previously only be done with human oversight. So I mentioned agentic AI a lot just then, and you're likely wondering what it is. And I think this quote that you can see on the screen from Eric Pounds at NVIDIA describes it quite well. So he says the next frontier of artificial intelligence is agentic AI, which uses sophisticated reasoning and iterative planning to autonomously solve complex multi-step problems. So let me explain a little bit more about how agentic AI works using a generative AI system as a comparison. So whilst the technology behind the generative AI tools that we use today, such as ChatGPT, is pretty complex, the process that the tool actually uses to come to an answer is quite simple. So we normally have a user, a large language model, and a web application or any kind of interface that's somewhere in the middle that the user uses to interact with the LLM, and the LLM passes its answer back to the user. So when the LLM generates its answer, it does this without the use of any external tools. So only its own neural network, which is trained on a vast amount of data from the internet. And whilst this makes the model great at conversation and does give it a good grounding of knowledge from its training data, there are a few issues with this approach. So firstly, if you want the model to use specific data to ground its response, such as maybe private business data, it won't have that context and is likely to hallucinate in its answer. And what hallucination means is when the models are trained on this vast amount of data, all they're doing simply is predicting what the next word in its answer will be. And if it has a lot of knowledge about a certain topic from its training data, this is more often than not the correct answer. But generally, when you're asking about something that's not in its training data, it will kind of predict the most likely word or the most likely answer, and this won't necessarily be correct. And secondly, if you want the model to actually perform an action, such as send an email or maybe query a database, it doesn't have the ability to do that. So these are the challenges that agentic AI really aims to solve. So this example flow that I'm just about to show you will show how a user interactive agentic AI system could work. So we still have the two-way interaction between the user and an LLM through some kind of interface. We're using a web application again as an example, but we call this large language model an orchestrator model. And this is because it orchestrates the entire agentic system. And we'll likely use a reasoning model for this task because the role of the orchestrator is key for the functioning of the agent. And agents are usually built to perform complex multi-step tasks. So that reasoning model that I talked about earlier is quite useful for this. So the orchestrator model determines what the user's request is, the steps to complete that request, and which of the tools that are available to it should be used to help come to the right conclusion. The ability for the orchestrator to call various tools is another key part of what makes a solution agentic. This means that the model can actually perform actions to achieve its goal. So for example, the orchestrator might decide that it needs to query a SQL database to retrieve structured data to help it answer a user's question, or generate a visual as a visual aid in its response. So this dramatically enhances the ability of a model to automate real business tasks. So one of these tool calls could actually be asking the user for any extra input that might help the model answer the question. So the key concept here really is that the LLM is processing the request of the user in a more step-by-step manner and is getting additional information where it can to help answer the query in the best way. And whether this is a call to the tools that it has on offer or whether it's asking the user for more information, it's using these different bits of useful tools and additional help that it can to come to a final answer. So finally, the model itself will decide when it has a satisfactory answer to the user's query. And at this point, it will send its response back to the web application. So it's the entire system, the orchestrator and the tools that make up an agent. So agentic AI is not a new type of AI. It's more of a revolution in the way that large language models are used to solve multi-step problems. So I want to break down for you some of the important innovations or patterns that make agentic AI systems so much better at solving complex multi-step problems than generative AI models alone. And through our conversations with customers and building these agentic systems, we've identified 6 key patterns that make agentic AI what it is. So these are tool calling, planning, review, memory, multi-agent, and finally, human in the loop. So the first and arguably most important pattern is tool calling. Tool calling is a usage pattern which allows the orchestrator model to lean on any number of predefined tools to perform actions that enhance the agent's capabilities. Tools generally fall into one of 2 categories. So they're either used to retrieve some contextual information for the orchestrator to help it with further actions. So an example of this would be maybe querying a database to access enterprise data or retrieving documents like standard operating procedures so that it can follow some standard steps to complete a task, or maybe even searching the web for extra contextual information to help it answer the question. Alternatively, tools can be used to take actions such as sending emails, raising support tickets, and triggering additional automated processes. The possibilities here are virtually limitless for tools, provided that they can be coded into our system. And this is a pretty important point, which I'll come back to a little bit later on in a couple of slides. So more generally, to set up tool calling with an agent, you first need to understand what types of questions and tasks are going to be asked of the system. And then you'll need to consider, curate, and maybe sometimes build a relevant set of tools for the agent to use. And if you're familiar with programming, you can think of these tools as like a function call that the orchestrator can go to. It can call any of the tools at any time. We then need to grant the model access to those tools and give it the autonomy to decide when it's appropriate to use a certain tool. When it's appropriate to use a certain tool, make a call to the tool, collect the response, and use that response to continue in the process of answering the user's question or completing the assigned task. And one of the really important developments in this area that's made this development process of the tools connecting to the model and the model viewing the tools much easier is something called Model Context Protocol, or MCP. So MCP was first introduced by Anthropic at the end of 2024. But since then, it's really become widely adopted across model developers and platforms, with OpenAI, Microsoft, AWS, and Google all announcing support and providing information for developers on how to apply MCP with their models and tools. So what is MCP? It's an open standard for communication across AI models, tools, and context. So previously, models out there and tools that we might build and so on could be communicated with via APIs, but those were often custom designed and very specific to the component in the overall architecture, which can make for a lot of effort for developers. For example, if I wanted to integrate a tool with one model, I might need to build that tool integration in one way, but then if I want to connect that same tool to a different model, I might need to completely redesign the communication pattern. So a major win for people that are using MCP is that you can define a set of tools only once and then reuse those across multiple AI models and agentic systems. So the tools or functions can be written as maybe Python, JavaScript, or any language you want, just written as functions in those languages. And then the MCP server will actually take the load off us and handle how to give the instructions to the model and which tools are available, and then also provide those results from the tool calls back to the model in a standardized way. So this also plays into the important consideration of optionality, because you don't want to get locked down into using maybe a single model or a single platform just because it's really difficult and you'll have to redesign your communication patterns between your tools if you want to move. So MCP really enables that level of modularity and reusability that matches pretty much what we preach in terms of designing any data-focused system, not only AI systems. So I'll now hand you over to Aaron, who's going to show you a demo with an enterprise use case, which will show you a little bit more about MCP and tool calling.
Thanks, Ethan. So hi everyone. Before we go into a bit more detail about Agentic AI, I'm going to show you a quick demonstration of an example use case that we've created showing how Agentic AI can be used to tackle some real-world problems. So for today's demo, we'll be adopting the persona of a procurement team member at a fictional confectionery company, the Sweet Dreams Chocolate Company. Now, this role involves a variety of different things, such as monitoring accounts payable, reviewing and validating supplier invoices, monitoring purchase order budgets and vendor relationships, and escalating any issues that might need management review. But this role is not without its challenges. Every day, we have to switch between multiple different systems for individual tasks. We have to cross-check invoices against complex standard operating procedures, and we have to chase approvers for urgent exceptions. It can be slow, repetitive, and take us away from completing higher value work. And this is where our AI agent comes in. So it's designed to tackle these challenges by giving us instant access to critical data, such as our supplier details or purchase order details, without us having to dig through multiple different systems. It can autonomously execute workflows, such as validating an invoice and forwarding any issues to the right person automatically. It can help free us up to progress with some other tasks that we've perhaps been too busy to tackle beforehand. So to contextualize this use case, I've created a process flow diagram of the AI agent. It starts with our users, so the procurement or me in this example, who interact with our agentic model through a custom web application that we've created. We have our orchestrator model, which in our case is one of these large language models, and we have created some specialized tools for the orchestrator to use, completing our agentic model. Now, these tools give the agent the ability to read our financial guidelines and query our financial systems. For example, the Get PO Details tool queries our internal databases to retrieve information about specific purchase orders. These tools give the agent the ability to reach out to people throughout the organization, to alert them or request action if any is needed. And as mentioned earlier, these tools are available for the orchestrator to use, but they are not mandatory. The orchestrator will choose which tools, if any, it should use, depending on the query. As mentioned, this is the custom web application that we've created. It sits on top of our agentic model, and it allows users to interact with that model through prompts and text. We have the settings tab here, in which there are two different drop-down menus. The first, we can choose our orchestrator model or large language model. So we can choose between Claude or OpenAI or Llama or Gemini, kind of really highlighting the optionality that we have between swapping out the different models depending on our wants and needs. We also have these different tool sets. So I'm going to use the invoice audit tool set. And if I hover over the show available tools icon, I can see the available tools such as the Get Invoice Review SOP, the Check PO Supplier, and these are all the tools that I showed in the slides. So as I mentioned, the orchestrator is just a traditional large language model, and we can interact with that large language model by asking a really basic question that in our role we should already know the answer to. So the first question I'm going to ask is, hello, please can you explain what accounts payable means? Now, as I mentioned, this is a simple question that we should know, but also we could go onto ChatGPT, for example, and we could ask it this question, and it should be able to answer, because there's no further information or specific business context that's needed. So as you can see, the question is being passed through to the orchestrator. It's then looking at all of the tools it has available. And in this case, it's deciding that none are needed and it can answer it itself. So accounts payable refers to the money that a company owes to its suppliers, vendors, or creditors for goods or services that have been received but not yet paid for. But what if we wanted to go further than this? What if we wanted to ask a more complicated question that a traditional large language model couldn't answer on its own? As Ethan mentioned, tool calling is just one thing that differentiates agentic AI from traditional large language models. Now, in my role in the procurement team, what if I wanted to find out some information about a specific purchase order? So how much is left on the purchase order 265012? Now, I'll pass that through again to the agent. One thing to call out at this point is we've made the model a little bit more verbose than you'd probably make it in reality. So we can see what the agent is thinking in these blue boxes, and we can see what the model is answering in the orange boxes. This is great for developing and demonstrations, but you probably wouldn't deploy this because it's not overly aesthetic. You can see here that the agentic model has called a tool, get PO details. It's then passed through the purchase order ID and returned a result before wrapping up in a nice neat message saying there is 50,000 USD remaining on this specific purchase order. Now, this is one of the things that's the difference between agentic AI and large language model, is its ability to query business-specific data. And this can be really useful also, as there was no need for us to go to a specific website or technology. We could just ask it in the agent here. Now, my role in the procurement team also requires me to work closely with our vendors. So later in the day, I've been asked to do some vendor relationship management, and I've been given a vendor ID. But we have so many different vendors, I want to double check exactly who this is. So if I just ask, which vendor has the ID USEC1033? Now, you can see here that a different tool has been called. It's the Get Vendor Details tool has now been called, passed through the vendor ID, and some information, including the vendor name, has been returned and replied in a nice, neat message. Now, this highlights the intelligent nature of agentic AI. The orchestrator has chosen the correct tool based on the query, and it highlights how this can be used to tackle a variety of different problems within the same system, which can be extremely useful. Another extremely useful element of agentic AI is its ability to execute complicated workflows. So far, we've asked some fairly basic questions. But what if we wanted to ask a more complicated question? So as I mentioned, I'm in the procurement team, and I've just received an invoice from one of our vendors. You can see here that there's a variety of different details coming from the invoice. There's some information about the vendor itself, who it's billed to within our company, purchase order information, and a table below on the items provided. So the item description, specifications, quantity, total price, etc. You can see that this is fairly structured, so there's a bit of a semi-structured table at the bottom. And if we want to do this as humans, we could go through and probably extract that information. But sorting this out programmatically would probably be quite difficult, as invoices come in all different shapes and sizes, and they're not necessarily all going to be easy to read for a computer. So we want our agent to validate this invoice. And now if I pass this PDF through to our agent and say, please validate this invoice. Now what's happening is the agent is looking at all of the information it's being provided. So this is the prompt, and in this case also the PDF. It's looking at all of the information and the tools it has available to it, starting to come up with a bit of a plan of action and working through that plan to the best of its abilities. It's going to keep going until it thinks that it's finished with this task. And as you can see here, it's still going because it's a fairly large, complicated issue. So going back to the top, you can see that the agent has said, I'll help you validate this invoice by checking it against our standard operating procedures and verifying the details. It's then called the tool Get Invoice Review SOP, where it's gone to our SharePoint site where we have a variety of different standard operating procedures. It's pulled back the relevant one, and it's used this as the base for its plan of action. It's then worked through this standard operating procedure, calling the relevant tools, extracting the relevant information from the so the purchase order details and the vendor details, before going through that standard operating procedure and wrapping it in a nice neat message for us to look at. So we can see here that a critical issue has been identified. The invoice fails its validation because the purchase order has expired. Fortunately, the invoice has passed some other checks, so it's given us some information that the invoice details are correct, the vendor information is complete, verified, but some action is required. So due to the expired PO, the invoice cannot be processed for payment, And here you can see another really useful element. The agent is sending a notification to the approver. So as we've given it the ability to send an email notification, it's now taken action and it's emailing the relevant person, so in our case, Sarah Johnson, to try and get some further information. You can see here at the bottom as well, recommendation, this invoice should be rejected for payment until a new purchase order is issued or the existing PO is extended. The approver, Sarah Johnson, has been notified of the issue and will take corrective action. You can see here that the agent has taken on the information and decided on a plan of action based on what it had. The agent then executed that plan using its tools and took action to email the approver. It finished when it believed the task was finished. And it's a great example of how an AI agent can be used to automate a process and take autonomous action. Just looking back at our demo, we saw how the agent answered a few different questions, from a simple question about accounts payable all the way through to the agent completing a workflow and validating an invoice for us and taking action. The agent was able to look at the information provided to it, so the question and any supporting documents, before then looking at what tools are available to it to tackle the problem, and then intelligently using those tools in the correct order to return a suitable response. The agent was also able to appropriately understand the complexity of those questions. So, for example, only using one tool for a simple lookup, but multiple tools for the complicated workflow. Hopefully, this demonstration has highlighted just how useful agentic AI can be, tackling a variety of complex business problems and automations. I'll now pass you back to Ethan to continue with the slides.
Thank you, Aaron. So I hope that that demo gave you a good understanding of how agentic systems use tools to achieve a specific goal. But there are still 5 other processing patterns that make agentic AI so good at solving complex problems. And I want to take you through some of the rest of them now. So the 3 I want to cover now are planning, review, and memory. And these differ a little bit from tool calling in that rather than adding more components into the architecture, they focus more on how to help the agentic AI system think, if you will, and solve problems in more holistic ways. So I'll start with planning. And it's useful to think about how agents plan in terms of how we would go about solving a complex problem ourselves. So generally, we don't say, I already know the solution, so I'm just going to start writing the answer out. More often or not, we'll start with an outline of what steps we're going to take to come to a decision. We'll try and list down what are the key topics that we want to address and the decisions that we need to make, and what tools we can use to help us get to an answer. And this is really the same thing that's implemented in agentic AI systems, or in most agentic AI systems, I should say. The user will generally input a prompt, and rather than immediately producing a response, the agent takes a second to think about and design a suggested approach to arriving at that response. And then it enacts that, it's laid out for itself. And here you can really see why it's useful to have some of those reasoning models that I talked about a little bit earlier here, because they already do this kind of thought process already. So they're very good at this kind of planning and then acting pattern. So here's an example drawn from the Thoughts feature in Google Gemini. And in this example, we're working for a fictional medical devices company. And in this company, we've recently developed a device that was very successful in the United States, but we're now thinking about a potential European market entry. So we're asking, should we do it? Quite simply. So rather than immediately saying yes or no, and then trying to justify why, the model is laying out its own plan. It's making sure to understand the core task, identify key stakeholders, and structure its analysis. Then it's thinking about how it will refine and review its response. And we'll come back to these in a second as they're a different agentic pattern. But this is really all before coming up with the final response and recommendation on whether to go ahead with that market entry. So by planning out its response first before delivering a final answer, the answer is much better laid out, and it's a much better exploration of an open problem than it would have been without this planning process. So I just mentioned review there, but the review pattern is kind of the opposite to planning. And the idea really comes from the idea of if I asked you to write out an essay, but I told you once you sit down and start typing, you need to write the full paper all without ever hitting backspace. It would be a really hard way to solve that problem, and no one really in their right mind would ever do that. And to some extent, no matter how good or big or powerful of a model that you make or use, if you force it to take that path to solving difficult problems, it might really limit the effectiveness in returning good solutions. So reviewing allows a level of iterative feedback. So the model will first write a first draft response, but rather than immediately returning it back as an output, it passes it back to itself or maybe a different model for review, and it will get feedback on the draft response. Then it will take that feedback and then ultimately rewrite and apply that feedback in its final answer. So this review process can really help the orchestrator model to correct any mistakes that it has in its planning or in its final output. And this really drastically increases its accuracy when completing tasks. So memory is another interesting pattern in agentic AI solution design. So a lot of times you're not the first person to have asked a question. Somebody's generally asked that question before, they've tried to solve it before, and there's probably some information out there that if we knew it would be really helpful when it comes time for you to ask the question and for the model to try and solve that newest iteration of the problem. Or maybe there are pieces of information that when you're interacting with a solution, you're assuming or just know in the back of your mind, but you haven't necessarily explicitly shared those with the model, but maybe you have in other instances or other conversations. And if we could remember those, it would be really helpful in making sure we're answering the question in the best way for you. So recently, we've started to see the concept of memory implemented in some of the AI tools that we use day to day. So on the left-hand side of the screen, you can see ChatGPT's implementation of memory. So OpenAI have integrated this feature into the tool, saving small snippets or pieces of information from your conversations to help influence how the model responds to future prompts that are not necessarily within that same chat or conversation that you're in. So the idea of the memory pattern is that when important pieces of information are shared with the agent, such as a correction maybe to its method of solving a particular problem, or maybe some crucial information about a standard operating procedure that maybe isn't necessarily in the document that it's getting that procedure from, the model can choose to commit this information to long-term memory. And this allows it to use that same bit of information in other conversations to improve its responses. So it's kind of learning over time how it should respond to you. And in enterprise context, memory is an aspect of agent design that needs quite careful consideration to get value whilst avoiding data leakage. So for example, if you have an agent that handles interactions with different suppliers, maybe you work for a company that handles different suppliers, external suppliers, you wouldn't want to persist memory across conversations with different suppliers, as this would risk confidential supplier information being accessed by their competitors. So whilst you can design your memory function in a way that prevents this scenario, and many companies have done, it requires very careful design and planning when developing the agentic system, and really before you start developing the agentic system. So we've covered 4 of our 6 agentic AI patterns. We saw augmenting our process flow with calling additional tools, and we saw trying to think about how to solve problems more intelligently through planning, review, and memory. So there are 2 really remaining here, and these 2 are multi-agent and human in the loop. And these get a little bit more towards tool architecture and design. So I won't cover them in too much detail during this session, but I will just give a brief overview of what they are now for you. So multi-agent is essentially the concept of incorporating multiple reasoning models into an agentic AI solution. So this can come in useful when you want to provide multiple perspectives during planning and review, or dynamically select which models of which size, and importantly, which cost are aligned to which types of tasks. So you may have a quite simple task that the agent is performing, and you have one orchestrator model which will say, okay, this task is fairly simple. We'll direct this to a smaller model, which is generally quicker to respond and also more cost effective. But if we have a problem that's going to require multiple steps, like when Aaron showed you that multi-step invoice processing problem earlier, we might want one of our larger models solving that problem. So this means that we're solving the right things at the right level of complexity, really. And finally, human in the loop, we might have certain edge cases in a process that get flagged to us for manual review and input, and the tool will wait for that input before proceeding with the subsequent steps. And this is where we're bringing in the human like a tool that the agent can call here. And this is what we got to see a little bit of in Aaron's demo as well, through this email alerting system. It's gone out and it's sent an email to someone who needs to review a certain invoice and the purchase order related to that invoice. So this just allows us to kind of take bits of the process for human oversight where that's needed, as it will be needed for many processes. So this is a really important pattern, as many workflows that could be automated using an agent will be important business processes that require some human oversight or accountability. So having a human in the loop is really essential in these scenarios. Otherwise, it might be a blocker to adopting the agentic system at all. Okay, so that is all we wanted to cover today on agentic AI. I hope you found what we went through informative, and hopefully you now have a good grasp of what agentic AI is and how it can be useful in your organization. So if you are interested in finding out more about agentic AI systems or how to implement them, then at Thorogood, we would be more than happy to help you out. So just to give you a little bit more info on who we are, Thorogood is a global independent data and AI consultancy. We combine our strong business focus, data understanding, and the latest technology expertise to help guide you from end to end in your journey. Our consulting services range from end-to-end data solution delivery and solution design to tool training, data strategy, and roadmaps. And we operate across the whole spectrum of data and AI, so from data visualization to data engineering, data science, and most importantly for this webcast in the AI space as well. So like I said, please feel free to reach out to either me or Aaron through LinkedIn or by email, which are both shown on the screen, if you do want to know more about agentic AI or how we can help you and your business with anything data and AI. So I hope you enjoyed today's webcast, and we hope to see you at another one soon.